Hello students. The question says we should use the matrix method to actually solve the system of equations that we have. We have A and B. So I'm going to work out this, then you work out B on your own and tell me the answer in the comment section. Now, moving straight to the solution, what we need to do is to form the matrix of the system of equation. And how do we do that? We pick the coefficient. Now, from the first equation, which is equation 1, what I'm going to do now from equation 1 is I'll pick the coefficient, which is 1, 1, 1. Okay, if you check, the coefficient here is 1, and the coefficient here is 1, and the coefficient here is 1. So we're done with that. The second line, which is equation 2, the coefficient is 2. The coefficients are 2, minus 3, and 4. Then the coefficients of the third line will be 3, minus 1, and 2. Now, this is to form the matrix, okay? So this is a matrix of it. So we are done with that. Then we are going to form a matrix of the unknown. This is the method of doing it, okay? So the matrix of the unknown, we have X, we have Y, and Z. Now this will now be equals to 14, 17, and 14. So we form the matrix. That is the method of doing it. Okay, so take note. Now, once we have this, let's say, so we can continue this as, let's represent this as A, then let's represent this as B. Let me put arrow so that you understand what I'm doing. Then let's represent this as C. I want to show you something. Now, do you know this is equivalent to saying A times B is equals to C? Now, what we are looking for is the B, which is the unknown, the one that contains the X, Y, and Z. So it means that my B will now be equals to C over A, okay, which we can write as A inverse then C. So you see, this is very important. So in actually working out this type of work using the matrix method, it means that A inverse is very important. Very, very important. So it means that we have to go get A inverse. Okay, now we have our matrix A, and the inverse of A is having the formula 1 over the determinant of A multiplied by the adjoint of A, okay? Adjoint A. It is very important that you take note of this. Now, we will start with the determinant. I'm going to be explaining the adjoint of A later. That ADJ means it is adjoint of A, okay? So we are going to talk about it later. So let's go quickly to get the determinant of A. Now, determinant of A, which is like this, is actually equals to what you see on the screen. Now, this is the method of doing it. Now, remember, this is positive, negative, and this is positive. So, we are going to use the cover-up method, where if we cover this one, the first letter 1, which is positive. So if you wish, okay, you can write the 1 if you wish, but it's not necessary. But let's just put it for effect's sake. You know, what you are going to be left with will be, you see, once you do that, what it means is that you cover this and you cover everything. That is the row that has to do with that one and the column that has to do with the one. So what you'll be left with will be minus 3, 4, then minus 1, 2. That is the method of doing it, okay? Now, this next one is going to be negative, right? Negative. Then you have 1. If you wish, you can put it that way, like I said. Now, if you cover the row, if you cover the row of this one and the column of it, what you're going to be having will be these 2, 4, 3, and minus 2. So I have 2, 4, 3, and 2. So this is what I have. Okay, now the last one is a positive one, so if you wish you can still put the one, but it doesn't have any effect because it is one. Now once you cover that, you find out that your answer will be 2 minus 3, then you're going to have 3 minus 1. This is what you have. Okay, very important. Now the determinant of A is now going to be this. Now this is the method of doing it. You are going to multiply the right diagonal by then subtract the left diagonal from it. That is the product of the left diagonal. So what you are going to have now will be, instead of writing this one, there is no need again. Okay, I'm going to have it this way. So I have minus 3 times 2, then minus into 4 times minus 1. This is what you're going to have. Then minus into, we have 2 times 2, then we have minus into 3 times 4, right? We have the bracket, then plus, we have 2 times minus 1, then minus into 3 times minus 3. You cover the bracket. Now, A, determinant of A will now be minus 6, then we have plus 4. If you know your mathematics well, you know that it is correct. Then this is going to be 4, then minus 12, cover the bracket, then plus what we have here is going to be minus 2, then plus 9. Okay, so this will now be minus 2. This is minus 8 times minus, so we have plus 8. Now this is 7. Okay, so we have 7. Now what we have here will be 13. So that is determinant 13. So we've gotten the first thing, right? Then let's go to adjoint of A. What does that mean? Adjoint of A. I told you I'm going to talk to you about it. So the adjoint of A. Now, the adjoint of A is actually going to be the transpose of the cofactor matrix of A. Now, what do we mean by this? I'm going to be explaining this word transpose. I'm going to be explaining it when we continue, okay? Now, but the immediate thing to talk about here is cofactor. What does that mean? Now, let the matrix of the cofactor be B, okay? Let the matrix of the cofactor be capital letter B. So how do I get the matrix of the cofactor? Now, it is very important that we take note of what I'm going to be doing now. All right. Now, similar to what we did with the determinant or finding determinant of A, that is what we are going to be doing here. Now, look at, if we cover this one, what it means is that all the rows and the columns that has to do with 1 will be taken off. So what I'm going to have will be minus 3, then 4, minus 1, and 2. Okay, I'm done. Now, when I cover the next, that is, I'm covering this one now. If I'm covering this one, what I'm going to be having now will be 2, 4, then 3, 2. Okay, then I will cover the last. Once I cover this one, what I'm going to be having will be a matrix of 2 minus 3, then 3 minus 1. But that is not all. We'll continue. Now, that is the difference between this and that determinant thing we did. So I'm going to cover 2. Once I cover 2, now let me show you this. It means that everything that has to do with 2 is taken off. So what is going to happen here is that we are going to take off this row, okay, and take off this column. So if you check, what I'm going to be having will be 1, 1, minus 1, and 2. I want to believe you understood what I've done. So I'm going to have, just like I told you, it's going to be 1, 1, minus 2, sorry, minus 1, not minus 2, then minus 1 and 2. Okay, so I'm done with that. Now, I'm not done yet. I'm going to cover minus 3. Now, once I cover minus 3, I'm going to end up with this, and this, and this. Okay, so I'm going to end up with 1, 1, then 3, 2. All right, so this is exactly what you need to do to cover up the space. Let me do the last one now on this row. Now I'm covering 4. What I'm going to be left with will be 1, 1, but this time around it's going to be 3 minus 1. So this is how to do it. Now looking at the screen, you see everything is now completed. So I can now get my B, okay, as being B will now be a matrix of what I'm going to be doing now. You see, I'll multiply this, then multiply this and find the difference. Now, if you do this, you are going to have minus 3, sorry, times 2, which is minus 6. Then we have minus 1 times 4. I think we've done it before, right? And what you are going to get in this case will be minus 6 minus 4. So the answer is minus 2. We've done it before. I just want to show you so that you know that this is exactly what I'm doing. I'm going to do it for all of them. Right now, doing this, here is going to be minus 2. Now here, this is 4 minus 12. I'm going to have minus 8. Then this is going to be this times this is minus 2. Then I have minus 2 plus 9. What I'm going to have, it will be 7. So I'm done with that row. This is 2, then plus 1, I have 3. Okay, that is how you're going to fill it in. So let me just fill it in. Okay, now I've completed it. But before I put it back into this matrix B, you must take note of this. This is going to be multiplied by plus, it's a positive. This is going to be multiplied by negative. This is going to be multiplied by positive. This is going to be multiplied by negative, by positive, by negative. Then this is by positive, by negative, and by positive. All right. So everything changes. All right. Some will remain constant, but majority, like the first one is going to be minus 2. I don't have any problem. Now look at the second one. Minus 8 times minus 1 is going to give you, or times negative is going to give you plus 8. Then the last one, of course, is 7. Nothing changes. Then this is going to be minus 3. Then I have minus 1. Nothing changes there. Then I'm going to have 4. Then I'm going to have 7. Then minus 2. And the next, or the last one, I'm going to have minus 5. Now, I've gotten this B, which is the cofactor. All right. Now, I need to get the adjoint of B. Now, the adjoint of B in this case, now I have to explain what adjoint is to you guys, okay? Now, adjoint simply means interchanging rows with columns. That is, making the rows or making the columns to be rows. Or in just summary, just changing the rows to columns. Let me put it this way. Now, what I mean is, you see this? I'm going to take this row so that it will form a column of minus 2, 8, and 7. The same thing, I'm going to pick this row. That is how to form the transpose. All right. Okay, I wrote adjoint. Not really adjoint. Let me make a correction here. It's transpose of B now. Okay, that is what I'm looking for. Transpose of B. All right. Sorry for that. Then I will continue. This is going to be minus 3, minus 1, and 4. Now picking the last one, I'm going to have 7, minus 2, and minus 5. Now I've done this. So I've gotten the transpose of B, which is actually the adjoint of A. So this will now be the mean, or that is the adjoint of A. So I've gotten it. Now it means that finally I can get my inverse now. Now A inverse will now be equals to 1. Remember, let me write the formula so that you won't forget. Then into the adjoint of A. Now this A inverse will now be 1 over. Don't forget, we got our determinant to be 13, I guess. Let me check. Okay, 13. Look at it here, 13. So I'm going to have 1 over 13. Then is going to be into the adjoint. So this is going to be minus 2. I have minus 3, then 7. I have 8 and minus 1 and minus 2. Then I have 7, 4 and minus 5. Okay, so I have succeeded in getting my inverse. Then let me go back to remind you what we actually are supposed to do. Now, we are going to pre-multiply the inverse, okay, in this expression. We are going to pre-multiply both sides. So let me write it down so you can check it on the screen. Now, this word is very important. You pre-multiply both sides, all right, by the inverse of A. So what is the inverse of A? Remember, we've gotten it inverse of A. Now, let me write it here. This is going to be 1 all over 13. Then into. So if you check the screen, everything has been pre-multiplied, okay? That is the expression. So the next thing that I'm going to do now is to have this, okay? I'm going to be multiplying, but I want to show you something. You see, you have to note the fact that when an inverse of A multiplies A, the answer is I. And I is an identity element. Sorry, not element, identity matrix, okay? Identity matrix. Now, what do you mean by identity matrix? Okay, this is a 3 by 3 matrix, a 3 by 3 square matrix. So the identity matrix is actually going to be 1 0 0 0 1 0, then 0 0 1. So this is it. This is what it will give you. So no need to do anything. All I need to do is to come down to write my identity matrix as 1 0 0, then 0 1 0 0 0 1. Now you see this thing that I just showed is actually something that you need to know. Okay, it's an identity you need to know. That is the definition of identity matrix. Now, but if you don't know this, it means that you have to multiply this. You have to do the matrix multiplication, which is a bit long. It will make the process longer. So if you know this relationship is better for you, okay? Now I have my x, y, z. This x, y, z. Very important. Now is equals to. Now good. So we have this displayed on the screen. Now I'm going to use another identity to make it look better. Now you see these two, when I multiply them, this is what is going to happen. Take note that when an identity matrix or a unit matrix, right? You call it identity matrix or a unit matrix. Let me write it. Unit matrix multiplies any given matrix, the result does not change, or you can say, or the matrix remains unchanged. Very important. So it means that the whole of this will still be maintained as x, y, z. So it is very important. We are moving. We are almost done with this question. It's lengthy, but it's interesting. Now, you see the right-hand side. On the right-hand side, I must actually multiply. So I'm going to show you how to multiply now. Okay? Now, to multiply it, I'm going to pick these two to multiply. Okay? Let me show you a very simple way of multiplying it using a table. All right? It's very simple. So you watch me. You know, it's row by column multiplication. So I'll pick this row. So that I'm going to have minus 2, minus 3, and 7. Of course, in this I have 14, 17, and 14. Okay, I'll pick the next one, which is 8 minus 1 minus 2. Then I pick 7, 4 minus 5. Okay, so I will now multiply. Now this is it. 2 times 14 is going to be minus 28. Then that is minus 2, of course. Then minus 3 times 17, that should be minus 51. Then 7 times 14, that should be plus 98. So I'm going to have my answer here. The next one I'm going to do is 8 times 14, which is 112. Then I have minus 17. Then of course I have minus 28. I'm going to have my final answer here. The same thing, what I'm going to do here, 7 times 14 is 98. Then 4 times 17 is going to give me plus 68. Then this should be minus 70. I'm going to have my final answer here. So let me add them and write the answers. So the first one will be 19. And the second one, when you total it, you're going to have 67. And the last one, if you total, you're going to get 96. All right. So everything has been done. I've multiplied. So it's going to be like 1 over 13 into, is going to be 19, 67, and 96. All right. Okay, good. So I will come back to my work, so that I'm going to have, this is going to be 1 over 13. Then into, I have 9, 67, and 96. This is what I have. Okay. Finally, this x, y, z. Now, multiplying the factor 1 over 13 into the matrix, I'm going to have something like this, which is going to be 19 over 13. I'm going to have 67 over 13. Then I will have 96 over 13. Now, comparing the terms, I'm going to have my final answer by comparing the terms. So my x will now be equals to 19 over 13. Then my y will now be 67 over 13. Then my z will be 96 over 13. So this is how you work out or you solve a system of simultaneous equations with 3 unknowns using the matrix method. It's very important. Now, you can go over the video and watch to really understand what I've done, but I've taken my time actually to teach you this. Now, you come back. Remember, I told you that I will wish that you do this and tell me the answer in the comment section. It is actually very simple. So I wait you to see your answers in the comment section, and I'm going to be very happy if you can get it for me. So guys, thank you so much for watching, and do not forget to subscribe to my channel for more interesting videos.